Okay, so here, this video is about a new invariant that we just found today. Take a 5 periodic orbit and an elliptic billiard, and I'm going to go ahead and draw its antipedal polygon. Okay, now to draw the antipedal polygon, what I need to do is the following. I take a point M somewhere on the plane, and I'm going to draw lines, construction lines, to each one of the vertices of the 5 periodic. And then I'm going to draw perpendiculars to these construction lines, and these are going to form this outer dashed polygon, which we call the antipedal polygon. I can animate that, and we can see it evolving. Okay. Now, I'm interested in actually placing M at one of the foci, so let's go ahead and place M on this focus here, on that focus there. Okay. Now, what is the interesting phenomenon here? I can observe the lines that, not the lines that are drawn here, but the lines that are drawn between a focus and the vertices of this antipedal polygon. Okay, so in order to do this, I'm going to go ahead and do the construction like so. Okay, now I'm actually drawing the antipedal polygon with respect to F1, and I'm drawing those lines that connect a focus to the vertices of the antipedal on one side, and I'm drawing a second antipedal polygon with respect to focus 2. And I can animate these two, and we get this kind of a situation here, n equals 5, right? So the two antipedal polygons are dissimilar. They're not symmetric, they're not similar in no shape or form. Now, the phenomenon that popped up today is that the sum of these red distances, okay, so the distances from focus 1 to the vertices of the antipedal with respect to F1, that sum of the dashed is equal to the sum of the dashed from the other focus. And we can see this over here. So here's one sum, and here's a second sum. Now they look invariant, but they're not invariant, okay? If I increase A here, the sums themselves are not invariant. And when I increase A this way, the polygon becomes self-intersecting, as you can see here. These pedal polygons become self-intersecting. Okay. However, the two sums are identical. So the sums of the red dashed lines, okay, from focus 1 to the vertices of its antipedal polygon is the same as the sum from the other focus. You can see here that this is represented by Q1 star 14.88. Q2 star 14.88, and I know that they are equal when I take their ratio and I get this 1.00. So dynamically, you can see that here. No matter what A is, so if I have a non-self-intersecting situation as we had before, these two polygons are dissimilar, but the ratio of the sums of distances is invariant and equal to 1. So, the sums of distances are the same. Of course, I can do this for the basic case of the triangle, and that's a pretty interesting thing. In order for us to see this, I'll reduce even more the eccentricity here, give it some space, like so. Maybe I'll put it at 3. Okay, and as I animate this, we can see here that the ratio of the sums of distances is preserved, even though these triangles are dissimilar. How do I know they are dissimilar? I can put them at symmetric. Let's increase A little bit. So I can put them at this sort of, isosceles position of the 3 periodic. We can see that one of the antipedals is this vertical triangle here. Let's try to make this even bigger so we can see it better. So, one of the antipedals is this one over here with respect to focus 2, and the other antipedal with respect to focus 1 is this sideways triangle here. They're clearly dissimilar, and yet those sums, sum of Q1 star and sum of Q2 star, they're always the same no matter what n is. So their ratio is 1. Okay, if I go to n equals 4, you get symmetric. So, I've been avoiding to talk about the pair guys, because the even sided and periodics, because the two polygons are symmetric, so they're similar, even though they have self-intersections. This is not as interesting, but what's interesting is when you have an odd number, and you can see here the polygons are completely dissimilar, and you get this sum of distances from one focus to the antipedal vertices equal to the sum from the other focus to the antipedal vertices.